Good morning. What are we going to see today? It is momentum. Okay. We'll directly go to the lesson. Now, what we will be seeing through the session would be how to apply conservation of momentum to situations, right? Now, I would say most of the students find it difficult or rather make silly mistakes or errors in calculations is when you are applying conservation of momentum. So, I'll be giving you some tips and tricks to keep in mind to remember while you're applying. Hopefully, you will not make mistakes and you will arrive at the right answer, right? Now, starting with momentum, I'll just quickly go through what the physical quantity is all about, why is it introduced, what is the significance of it, and so on. You may understand it better if I give you an example. Now, say if there are two objects traveling with the same velocity, say object A and object B, they are moving with same speed or velocity. You can assume 50 meters per second. Both of them are at the same speed and it comes and hits against an object, right? Could be a wall or any other object. Both of them comes and hits on the wall. Okay. What would be the impact on the wall? Will it be the same or will it be different? How would you come to a conclusion? Some of you might think both are traveling at the same velocity, so they should be having the same impact on this object. They might come to a stop or bounce back, etc., based on the surfaces and so on. But it's not the case. Okay. See, if I give you one more quantity that is related to it, you will get a better idea. Say if this object A has a mass of say 20 kg and there is another object B has a mass of 5 kg. Now, will the impact be the same? It will not be, isn't it? Because the heavier object obviously is going to cause much more damage than the lighter object. This is the reason momentum quantity is included in analysis of most of these collisions or crashes, etc. So that it will be easier for you to analyze the situation much better. Because if you ignore the mass of the object, the conclusion that you arrive at may not be apt for the situation. So we have to think about the momentum of the object, which is mass multiplied by the velocity. The quantities together, mass and velocity, will give you momentum, and the momentum of an object will determine what would the impact be if there is any collision of the object comes to rest or if it starts from rest and so on. All right. I hope you have understood the importance of the concept or the term momentum. Okay. Let's see what its formula is and what is its unit. Then we'll move on to conservation of momentum. The formula goes like this: momentum, actually which is either represented by capital M or small p, will be equal to mass multiplied by velocity of the object, right? Now, since velocity is a vector quantity, momentum is also a vector quantity. It also involves direction, not only magnitude. Direction is very important while you are discussing momentum questions. All right. So, what would the unit of momentum be? You can derive it from the formula. The unit for mass is kg, unit for velocity is meters per second. So, together this will be the unit for momentum. Kilogram meters per second is the unit for momentum. All right. Now, if you're asked to find the momentum of an object, it's a very straightforward calculation. All you have to do is just directly substitute it. But you have to keep in mind about the units. Mass converted to kilograms, velocity converted to meters per second if it's not already in the unit. Okay. Now, coming to the detailed analysis of conservation of momentum. What does conservation word mean? We saw that in energy. It is there is no loss in momentum, to put it in simple terms, right? So when there is a collision could be between two objects moving. We call that as, if they move opposite each other, we say head-on collision, or one object might go behind another one and hit, and so on. So there are different situations. But when there is a collision, the total momentum before collision, okay, or before the impact, will be equal to the total momentum after collision. I repeat, the total momentum before collision will be equal to total momentum after collision. Now, here there is a clause when there aren't any other external forces acting. Okay, For IGCSE level, they will not give you such complicated situations where there are external forces, but when you go to higher classes, you know, A level, AS level, or in college, when you are learning, you may come across situations where external forces are also you're considering and so on. But right now, if there aren't any other external forces, I'll give you an example later. Total momentum before collision will be equal to total momentum after collision. Now, this theory is very important in terms of, you know, real life situations where you're trying to find if there is a car crash or any other crashes of moving objects. If you want to find out with what velocity it was traveling before. Okay. For example, you know, in a road accident, if they want to investigate what was the speed of the car before impact, did it, you know, cross the speed limit, etc., all those can be calculated by using this technique. So it's very important in your real life application. So let's see how it works. Now, as I said, here we will only be considering two objects at a time. So in this calculation, or when you are applying it to any numerical problems, all you will be dealing with are two objects. So based on two objects, we'll write the formula. So total momentum before impact, since there are two objects, we'll take it as A and B. Say if the mass of the first object is m1, the second object is m2, and it's traveling with initial velocity of u1. This is before impact. So these are the values or the quantities before collision, and after collision, if they move ahead with velocity v1 and v2, right? Naturally, there will be a change in their velocities, right, because of the impact. So if that change in velocity, we take it as v1 and v2, how can we write it as a formula? So before collision, momentum of m1 will be mass into velocity m1 u1. Second object's momentum will be m2 u2. So this together gives before impact, right? Now what will that be equal to? Momentum after impact m1 v1 plus m2 u2. Now this is the basic formula that you will be using in all situations. Sorry, this is after. Now this is very similar to we did moments also. There also we had. So there also I have mentioned the formula is very simple. It's the same formula that you are going to use it for different situations. So what makes the problem challenging or difficult, or you're making errors, we'll see in a bit. This is where you have to pay very close attention to, right? Let's see what it is. Now, as I said, momentum is a vector quantity. So if the objects are not moving in the same direction, then you must consider about the direction of movement and change the sign conventions in the formula. Okay, that's the important part here. I repeat, if the objects are not moving in the same direction, either before or after, you have to consider about the signs of these vector quantities. Okay, it could be m1 could be moving in the opposite direction to m2 and so on. So that's where you have to pay, as I said, very close attention to. Now we'll take one simple example where it's a head-on collision. Okay, two objects are, now in the question they will not specify that they are moving in the opposite directions. They may not give you a hint or a clue that they are moving in the opposite direction. So you have to think before you apply, okay, in which direction are they moving. Now when they say head-on collision, it itself implies that they are facing each other and coming towards each other. So naturally one will be moving in the opposite direction to the other, right? So usually we take right to be the positive and left movement to be negative. So in this case, your m1, this momentum will be positive and this momentum will be negative. That's very important. All right. So if you are calculating it separately and substituting, while you are substituting, you make the change. This has to become negative. Got it? This is one such situation. Now, sometimes it may not be, they both are moving in the same direction. They come and hit each other and recoil. Recoil meaning it's moving in the opposite direction to its initial motion. Okay. So keep the term head-on collision is opposite to each other. Recoil term is also important, that it itself, the moment of the same object itself, will be in the opposite direction. So you have to look for these key terms in your explanation or in your situation that you are analyzing. Recoil and head-on collision, where the directions, it may not be specified, but you will have to understand it, interpret it correctly and apply it. Clear? Now, another point to note is, after you are using appropriate signs and if you have substituted, then you arrive at an answer which gives you a negative answer, negative value. Say for example, you are trying to find out u2, okay, and you end up with a negative answer, say -5 meters per second. So what does this negative sign indicate? It indicates that the speed of m2 before collision was in the left. Actually, it is moving towards the left because you got a negative answer. If you end up with a positive answer, which indicates that the object is moving to the right. So if there is any quantity that is unknown, especially velocity, and you cannot come to a conclusion before solving whether it's moving to the right or the left. Keep that in mind. Unknown quantity, you cannot come to a conclusion unless and otherwise you complete the calculation. How do you identify the direction? By looking at the sign. If it is positive, it's moving to the right. If you end up with a negative value, it moves to the left. I hope you've gotten some idea. We'll see through an example, then you might understand better. A bullet of mass 10 grams is fired at 400 meters per second from a rifle of mass 4 kg. The question is, what is the recoil velocity v of the rifle? What is the recoil velocity v of the rifle? That's a question. You can pause the video now, look into the question carefully, read through it, try to solve it on your own, and then see the working and compare your answers. I hope you get the right answer, right? I hope you have solved the question. Now, I'm not sure how many of you wrote like this, but then I would advise you to write down the values, okay, what are all given from the question. Now, this will kind of help you avoid silly mistakes. As such, like if you have not included the sign convention sometimes, or I've seen most of the time students make a mistake of swapping the values. What they would do is, for M1 they will substitute one of the masses, like object 1's mass, and then after substitution they end up substituting M2's mass. That will kind of again mess up with the calculation. So you have to be consistent with the masses that you are choosing for both M1's and as well M2. So be careful in the substitution. So to prevent mistakes that you may make in your calculation, please follow these steps. Write down the values, check once before you substitute. All right. Now, if I take M1 to be the bullet's mass, now it's given in 10 grams and the rifle's mass is 4 kg. If you notice, see, when you write it here again, you can see the units do not match. So this is the time, as I said, for you to reflect, think about the units. So I will convert that 10 grams to kilograms to have consistent unit. So this will become 0.01 kg. Now, what about U1 and U2? What is the situation here? The bullet is fired from the rifle. Now, before impact, here the impact is the bullet leaving the rifle, which is very similar to explosions and all. If there is a single object, if they break up into 2 or more fragments, now there also you can apply principle of momentum, conservation of momentum rather. So here, before collision, since both the bullet and the rifle are at rest, these two velocities will be 0. Got it? I have substituted that. Now, after collision or after impact, the rifle is traveling at a velocity of 400 meters per second. Now, what will its mass be? It will still be the same, 0.01 kg. This bullet remains the same, 4 kg. Now, the question is, what is the recoil velocity of V2? Now, in this question, it's an example question, it's given recoil velocity, but it may not always be specified in the question. Now, after substituting, this will, the entire value will become 0 because m1 u1 product of 0, this is 0, momentum m2 is also 0. So before collision you have value 0 kilogram meters per seconds, right? Now that can be equated to this product plus this product, right? So 400 multiplied by 0.01, you will get 4. Momentum of m1 v1 will be 4 plus 4 into v2. m2 is 4, v2 is the question, right? Now when you change the subject of the formula, this will come to the other side, you will end up with minus 4 divided by 4, which cancels to give you minus 1 meters per seconds, right? As I told you previously, this sign denotes that the object is moving to the left to your positive direction. We considered all these movement to the right to be plus. So if you end up in a negative answer, which means the object is moving to the left. Okay, so the recoil velocity of the rifle is minus 1. As I said, two things, keep it in mind. One, momentum is a vector quantity, so in your substitution values you have to be careful about the sign conventions. Second, please check before substituting whether you have kept the units consistent as well as masses of each of the object consistent in your substitution, and also you have considered the direction of the object. I hope if you keep all this in mind and solve these momentum questions, it will be easy. If you have any doubts or if you have any questions, you can post it. I'll get the right answer for you. All right. See you in another video. Bye.